Hi guys. Okay, so today we're going to look at the arc length of a curve. So we're going to consider a curve in the plane defined by the function y equals f of x. Now, I've given you a picture here just of f of x is sine x, just for an example. If we want to find the length of our curve, we can do that by finding the lengths of these little red line segments to approximate, right? And if we find the lengths of each of these and add them up, it's an approximation, correct? Now, what's important to realize is, as the number of line segments increases, the better our approximation is. Now remember, if we let n be the number of line segments, as the number of line segments increases, okay, it's going to get closer to the actual arc length. That should be ringing bells and saying, ooh, this sounds almost like a limit. We'll come back to that. Okay, now if we had a line segment, we know how to find the length of a line segment. Remember, you learned your distance formula back in geometry, right? It was x2 minus x1 squared plus the quantity y2 minus y1 quantity squared. When you had 2 points, x1, y1, and another point, x2, y2, okay? Now, this x2 minus x1, that's the change in x. This y2 minus y1, that's the change in y. So we can look at the length of the line segment as the change in x squared plus the change in y squared. Now, if we do that, this is our typical distance formula that we learn in geometry. Now, because I know where I'm going to multiply this by 1, but I'm going to make the 1 look like delta x squared over delta x squared. Why would I do that? Well, when I do that, I'm going to put one of them as the denominator and one I'm going to keep separate. Now, also, when I have this fraction like that, if you have addition in the numerator, this is really delta x squared over delta x squared plus delta y squared over delta x squared, correct? So this piece becomes this 1, plus we still have, and it's okay if I do the division and then square, all right? And then I'm going to take this and put it in its own little radical that we're multiplying by. Why did I do that? Because the square root of delta x squared is just delta x. And we still have this square root of 1 plus the quantity delta y over delta x squared. Now, remember when we said back here that if we let the number of line segments increase, that's like when we had the Riemann sums, we let the number of partitions increase, right? Does that sound a little familiar? So if we do that, and we take the limit as n heads to infinity of the sum of all of these line segments, okay, that would be the integral from a to b of, now remember, when we change from summations, this delta y over delta x becomes our dy dx, right? And this delta x is our dx. Remember dx? So this came from the delta x, and this came from the square root of 1 plus the quantity delta y over delta x squared. Okay, so this is the arc length formula, but also we could rewrite it, instead of using dy dx, we can use f prime of x. So there are two ways to represent the arc length. If we're going to do everything in terms of x, okay, and our x is between a and b, then the arc length is either the integral from a to b of the square root of 1 plus dy dx being squared times dx, or the integral from a to b of the square root of 1 plus f prime of x squared dx. We can also find the arc length if the function is defined in terms of y. Now, if y is between c and d, then our integral goes from c to d, and it's the square root of 1 plus, now it's the derivative of x with respect to y quantity squared dy, or the integral from c to d of the square root of 1 plus f prime of y squared dy. Okay? Now that formula can make it seem a little tough, so let's see what actually happens, okay? We're going to find the length of the curve of f of x over the interval from 0 to 1. Now the first thing I'm going to do is I'm going to look at this function f of x. We've got 4 radical 2 over 3, x to the 3 halves minus 1, because I know in my arc length formula, there is a derivative needed. So let's find this derivative, right? Because we are in terms of x's, we're going to use that arc length formula where the arc length is the integral from a to b of that square root of 1 plus f prime of x squared dx. So let's find f prime of x. So we're going to keep our constant 4 radical 2 over 3 times, now with the x, we subtract 1 from the exponent, we get 1/2, but we have to bring down that exponent 3/2. The derivative of the minus 1 is 0, so that's gone. Let's see if we can simplify this a little bit. This would be f prime of x is, the 3's are going to divide out, and 2 is going to go into 4 twice, so we're going to have 2 radical 2, and x to the 1/2 is the square root of x, so this can be written as 2 radical 2x. Here's our f prime of x, okay? So this is f prime of x. Now, let's set up our integral. So our arc length is going to be the integral from a to b, so from 0 to 1 of the square root of 1 plus our derivative squared dx. Well, our derivative we just said was 2 radical 2x. Now we just have to do a little bit of work. So let's see, we're going to integrate from 0 to 1, and if we square 2 radical 2x, that's going to give us 2x times 4, right, because you have to square that too. That's going to give us 8x dx. Now to integrate this, we're probably going to want to do a u substitution. So our u is going to be what's under the radical, 1 plus 8x. Then we take the derivative of u, which is du dx, and that's going to leave us with 8. If we solve for dx, we'd have to multiply and then divide by the 8, so we have du over 8. So we also have to look at our limits. If x is 1, that means that u is going to be 1 plus 8, which is 9. If x is 0, that means that u is going to be 1 plus 0, which is 1. So we're going to have our integral, but not from 0 to 1. We're going to have it from 1 to 9 of the square root of 1 plus 8x is our u, and our dx is du over 8. So this is going to become 1/8 times the integral from 1 to 9, u to the 1/2 du. So I'm going to bring along my 1/8. Now to take the antiderivative u to the 1/2, we add 1 to the exponent, so that's 3/2. We divide by 3/2, which is the same as multiplying by the reciprocal 2/3, and we're going to have to evaluate from 1 to 9. Now 1/8 times 2/3, that's going to give us 1/12 times. Now I'm going to take that 9, and when I raise it to the 3/2, it means take the square root and then cube it. Minus, now we substitute in the 1, we take the square root and we cube it. So we still have this 1/12. The square root of 9 is 3, and if we cube that, we get 27. Minus 1 to the 3/2 is just 1. So we're going to have 26 over 12, which reduces to 13 over 6. Ta-da! And there we go. Now, yes, if you're taking the AP exam, and this is on the free response, you would be able to stop at this point once everything is numerical. But we also have to get you ready for multiple choice, so you're going to go all the way to the end for me. Let's look at another example. And you're going to love what this one says. It says set up an integral That means do not evaluate. And the AP does this a lot on the exams, especially if the question has moved to the non-calculator section. They'll let you set it up and you don't have to evaluate it. Or sometimes the integral is just too complicated for us to evaluate. Okay, so let's read this problem. Set up an integral that represents the length of the curve defined by the relation f of y equals 4 times the quantity 2 minus y squared on the interval from 3/2 less than equal y less than equal 3. So now our arc length, we're going to be using the formula that's defined in terms of y. So we're going to use the integral from c to d of the square root of 1 plus f prime of y squared dy. Okay? So the first thing we need to do here, we have f of y is 4 times the quantity 2 minus y squared. Let's find the derivative of f. We're going to say 2 times 4 is 8. Keep the inside, decrease the exponent by 1, times, now we have to do the chain rule, the derivative of the inside is negative 1. So if we simplify that a little bit, that's going to give us negative 8 times the quantity 2 minus y. So now our arc length is going to be the integral from, and we're going to use 3/2 to 3 of the square root of 1 plus, now we're going to put that derivative, which was negative 8 times the quantity 2 minus y. And if you want to multiply that through and make it 8y minus 16, that's absolutely fine, but not necessary. Then don't forget to square it, dy. And there you go, my dears. We set it up. Let's look at another one. Now we're going to find the curve which contains the point 0, 3. Whose length from x equals 1 to x equals 4 is given by this integral. I'm just going to rewrite this integral here so we can look at it. The integral from 1 to 4, notice that's our a, that's our b, of the square root of 1 plus 16x to the 6th dx. Now what you need to realize is, what is that 16x to the 6th? That's f prime of x squared. So if f prime of x squared is 16x to the 6th, that means we must have been squaring 4x to the 3rd, right? So f prime of x is 4x to the 3rd. And by the way, we know that this is going through the point 0, 3. So there's at least 2 ways we can solve this. We can do it the old pre-calculus way and beginning antiderivative way, where we say, okay, if f prime of x equals 4x cubed, we would say the antiderivative is going to be 4, add 1 to the exponent, divide by that new exponent, and don't forget to add c. So now we have f of x is x to the 4th plus c, but then you have to use the fact that we know it passes through the point 0, 3, and plug that in. 0 plus c equals 3, c equals 3. So now you know f of x is x to the 4th plus 3. So we know that d is our answer. However, I'd like to go through the fact that we can use the fundamental theorem of calculus now, right? That f of x, since we know f prime, and I'm going to use a letter different than x, so I'm going to use t. We know the derivative is 4t cubed, let's say, dt, and we can take the integral up to x. Now the question is, what number do we start from? Well, the number we start from is this x value 0, and we add this y value 3, okay? So if we do this, we're going to end up with 3 plus, now the antiderivative of 4t to the 3rd is t to the 4th, evaluated from 0 to x. So we have 3 plus x to the 4th minus 0 to the 4th, and lo and behold, we get the same answer for f of x. And it is up to you which method you prefer. Okay, I have two more questions for you. The first one is a distance traveled problem. So suppose we have a bug crawling on a window pane, following a path modeled by this function y equals x plus 2 sine x. The bug starts crawling when x equals 0 and stops crawling when x equals 3 pi. So we're calling for 0 less than equal x less than equal 3 pi. How far has the bug traveled? The bug is walking along this path. We're looking for the length of that path. That means we're looking at an arc length problem. Okay, so I'm also going to write our function here. Y is x plus 2 sine x. So this is the curve that we want the arc length for. So since we have y, but it's defined in terms of x, we're going to do the integral from a to b of the square root of 1 plus dy dx squared dx. So that means our arc length is going to be the integral from 0 to 3 pi of the square root of 1 plus, now we need to go find dy dx. Well, the derivative of y is dy dx, the derivative of x is 1, plus 2 times the derivative of sine x is cosine x. So we'll have the quantity 1 plus 2 cosine x. Don't forget to square that, extend my radical, dx. Now we're going to grab that from, you can just toss that number into your calculator, and we'll go do that right now. So we're going to put in our calculator page. Let me get my calculator. And we are doing the integral, so we go to our template key. Oh, look at that, it's highlighted, the integral, the definite integral. We're going from 0 tab to 3 pi, so 3, then go to the pi key, hit enter on the pi, tab, we need the square root, so control x squared, 1 plus, open parentheses, our derivative was 1 plus 2, go to the trig to get the cosine, put in the x, close the parentheses on the angle, close the parentheses on the derivative, then square it. Then you can tab out, make sure it's dx, and hit enter. So our arc length is 17.416. Okay, so we found that the arc length, or the length that the bug walked along, was 17.416. Last question, and this was an AP question. It was part, I forget whether it was letter C or D, of an AP free response problem. So here we go. Let f of x equal e raised to the 2x, and R is the region in the first quadrant bounded by the graph of f. So this curve here is f of x equals e to the 2x. The coordinate axes, so the x and the y-axis, and the vertical line x equals k. The region R is shown in the figure. Write, but do not evaluate, an expression involving an integral that gives the perimeter of R. Now remember, perimeter is the distance around the outside of a region. So the perimeter, we would have, let's see, first we would walk this distance, which from the origin up here is 1. Then we walk this distance from 0 to k, that has a length of k. Then we walk this distance from k up to f of x, that's f of k, which is e to the 2k. Plus, now to get this length, we need the arc length, okay? So we would have to do the integral from, and the x's are going from 0 to k, the square root of, that's got to look like a k, 1 plus, and we're going to have to find our derivative and square it. If we have e to the 2x, the derivative of e to the 2x is 2e to the 2x, and don't forget your dx, and all of this together, that's our perimeter. Okay, guys, have a great day, and I'll see you tomorrow. Bye.